so we're going to talk about defining ports and adapters, starting lightweight, and show you a very lightweight application that I stole from the book. Not my book, but from Alistair Coburn's book, Domain-Driven Design, how we integrate that. We'll talk about behavior-driven development, and where all that testing is going to fit in. We're going to talk about domain-driven design components, modularity, folder structure, test-driven development, everyone's favorite topic, end-to-end testing, and ask questions like, is this the same as the Onion architecture? Or some other architectures that you may have different names for, which are kind of similar. So we'll talk about that as well. So let's get started here with ports and adapters. So ports and adapters, formerly called Hexagonal Architecture. And I think most people do like hexagonal architecture. It has a better sound to it. Although ports and adapters really reflects what it is that this particular architecture is. Hexagonal just is like a cool word that you could just say, and I'm like, hey, I'm using the hexagonal architecture. So focuses on separating the domain logic from the infrastructure and places the domain at the center of everything. So the business, right? And if you have a complicated business, that's what this particular architecture is for. Lots of business rules, and you need to rigorously test what happens at that domain level. That's what this focuses on. So it allows external systems, UIs, DBs, APIs, to plug in via adapters, but that's an outside concern. And so you don't have to necessarily think about the UI when designing that particular domain. So that's what's really great about that. Design for testability, flexibility, maintainability as well. Great part about this particular architecture is that everything has its place, and that's the idea. So introduced by Alistair Coburn in 2005, but advancements have been made, things have been renamed, restructured up till maybe about 2015 as well. So it's gone through some changes, and although it's a simple technique, the naming, the purposes for certain structures have changed over time. And so that's the idea here. And by the way, take a look at this slide. Oh, so pretty. All right, excellent. So here it is, right? Mic drop, let's go have some lunch. So domain is at the center here, right? And that's what we focus on as far as the business. And we'll talk more about the domain a little bit later, but the idea for the domain is, see, it is a great picture. I see people taking snapshots of this. You know, like, that is an excellent slide. So yeah, the domain's going to be the business. The application is how we're going to wire multiple concerns of the business together. But within this application, we're going to talk about something called ports. Obviously, this is the ports and adapters architecture. So the port is going to be an interface, and the outside concern is going to be the adapter. At the infrastructure level around here is where you're going to be applying your framework, whatever framework that it is you would like to use, be it Spring, be it Quarkus, and it's not a Java thing, so you could probably do Ruby on Rails or other sorts of frameworks over on the infrastructure side. Okay, but I'm going to focus on Java, and I think a lot of us are doing Java, so I'm going to focus on that. But that adapter has connections to things to the outside world. So on the upper left-hand side, a CLI. So if I am writing an application that is going to be CLI-based, then that would be the adapter that we're going to connect to it. If I have a web framework that we see here on the bottom left-hand side, that's how I can connect things to it. If I have a messaging system on the upper right-hand side, so if you're messaging to a RabbitMQ or a Kafka, that would be an adapter that you would have set up. And then you have the database with the port and adapter on the bottom right-hand side. So I'm using a hexagon here, but I think the Onion architecture has a little bit of something right here, because the hexagon makes it look like, hey, you could only have 4 adapters on here, but that's not true. You could have as many adapters as you'd like. All right, excellent. Oh, and then the other thing here, the arrows go in. That's the thing about this architecture. That domain right in the middle there doesn't have any reference to your Kafka or to your PostgreSQL or anything like that. It is just the domain and no reference to the outside world. Everything else is going to point inward, so it can have a reference to the domain. And that's going to have to be that key rule when it comes to that port adapters architecture. Yeah. All right. So domain, it doesn't depend on anything, right? Again, the arrows go in. This is beneficial for loosely coupled architecture, easily to swap out the infrastructure. But you know what? That's some of those things like, oh, you got to swap it out, but you know, how often are you going to be needing to do that? But just in case you do, that's a nice thing to have around. Promotes testability and clear separation of concerns. So in that domain layer, which is this center part here, what we're talking about is core business logic, key business models, again, not tied to a database, not tied to a UI, pure functions or classes, and typically no side effects. And so what's a side effect? Side effect is if you have code that does something outside and you don't have any kind of like referential integrity. And so what do I mean by that? System out print line, or soon to be, I don't know if you know this, maybe I'm giving too much away for my talk tomorrow, java.io.println. That's going to be the new print line. I don't know if you knew that, but anyway, so print line is a side effect, right? If you print to a screen, I can't validate that. That's something that happens to the outside world. If I send something to a messaging system, that's something that happens to the outside world. That's a side effect. Those are side effects. When you update memory or update any kind of state, that's a side effect. So these kind of things, maybe the state would probably be the exception here, but I/O and everything like that is not going to be a part of that domain. Business decisions, policies, things like that. And again, a lot of these domains are very, very complicated. You think taxes, insurance, a lot of these companies that have booths out there are all complicated companies. Toast, right? I just can think about all the different things that when you make an order and when they have to cancel an order and et cetera, et cetera, et cetera. Like all those are complicated rules. Boom, that's what's going on the inside. And again, no frameworks, no technical concerns, no Spring. Some people are bummed out. Oh, no, but use your Spring, but at a different level. Okay, it's just plain logic that you're going to be thinking of. The application layer now is a little bit outward here. And the application layer is going to be where your services are located. So if you're a Spring developer, you have that at service. That's typically what's going to be in that application. Quarkus, I believe, as well has an at service, which represent, oh, it doesn't? Okay. Whatever it has on that particular layer, that would be that particular application layer, okay? And so within that layer, you have these notions here of something called ports, which are going to be interfaces that represent things that get done on the outside world, and that's where these ports will come in, okay? So input ports would be some like place order or send invoice. We typically use the word use cases, and this is one of the refinements that the book has explained as far as the ports and adapters. What you typically want to do on this left-hand side, which is typically your input side, is that these ports here should be a use case for a particular group or a particular team. So think like this port here is going to be for admin, or a port here is going to be for sales or things like that. That way you have kind of like a business role or a use case for you know, how to drive your application, okay? So delegates to the domain layer, again, inward. I should have put a arrow from that port into that domain, but the idea there is that it works on the domain layer, okay? Defines ports as interfaces for external dependencies, but it doesn't do those dependencies. So if I have something, and some of you are already used to the term repository in Spring, right? You have something called at repository, which represents the database. But my little slight disagreement with the way Spring does repository is that repository is technical in nature when it comes to Spring, right? Like persist, or, you know, find or other things like that. Whereas the if you have a port here for repository, we generally want to model that as a business, you know, function. So instead of persist, maybe I want to register a student. So register student has more business meaning than just like persist or save or things like that. But you get to design that interface however you like. Contains still no UI database or framework code. It's about orchestration, and it's about orchestrating your domain models. Okay, and that's what that application layer is for. So then we go into the infrastructure layer. The infrastructure layer is this outside layer on here, and this is where you design the specifics. So if I have a port, which again is just a blank interface for a repository, on the infrastructure, the adapter is going to be the actual database component that actually communicates to the outside world, or your Kafka producer or your Kafka consumer, right? Those are the concrete implementations, and you're going to have that in the infrastructure. This is where you'll wire in your components as well. So if you use Spring, if you use Quarkus, if you use Juice, or if you are the developer that's like, no, I'm not going to use a framework, I'm just going to wire things raw. Hey, you could do that as well. So up to you, whatever you want to do at that infrastructure level. So you implement the ports, your data access, your REST clients, your message brokers, you connect things to the outside world. Again, I have mentioned all this already. So that's the idea for that infrastructure. No business logic here, right? That's not the place for this. This is about wiring the components together, using whatever framework that you would like, and swappable without affecting the core logic. And that's the beauty of this, right? So cool. So what's a port? So in that hexagon, you saw the port at the application level. It is a interface. You don't know how that's going to be defined. That's going to be up to the infrastructure level as to how that's going to be defined. Technology agnostic. Again, no frameworks. Ports enable inversion of control. Domain declares what it needs, not how it's fulfilled. And I should really say here, the application layer declares what it needs, but the domain is the one that's going to be pushed through that particular port to do something, and that's the idea for that. They allow adapters to plug in without coupling them to any logic, okay? So that's the way that works. So the imports, which are going to be on the left-hand side, again, those are going to be use cases, and which is an operation that exposes things to the outside world. Implemented in the application layer and called by primary driving adapters. So this is the first time you're going to see this term here. When it comes to the left-hand side, that's called driving, meaning that the adapters are going to drive the way the application works. And on the right-hand side is going to be the driven, which is your domain, your application is going to interact with the outside world, and that side is going to be driven by what's inside, okay? So again, ports are interfaces. They enable the domain to be invoked, and you have use cases. So let's say, for example, here, this particular CLI here, it is going to be interacting with a particular adapter, and that adapter is the concrete implementation, which is defined by that particular port, okay? So pretty nice in the way that works. The out ports on the right-hand side are still interfaces, okay? Things like databases, API, messaging, filing systems, things like that. Declares what it's needed, not how it's done. And again, because the ports are just the interfaces, keeps the logic decoupled and implemented by driven adapters, which is this on this hand side. So we take, if we say, for example, your RabbitMQ, for example, from this particular port, you are communicating to the outside world, okay? And that's the driven side. So the adapters are going to be the concrete implementations of those ports. How is it that you're going to go about it, okay? And so this will be your database calls. This will be your Kafka calls, your RabbitMQ calls, or things like that, okay? Maybe a REST call, and they belong on the infrastructure layer, okay? In adapters are going to be REST clients or CLI. How are you going to be interacting with your application? That's how that's going to work, okay? So I think we have discussed that one. Oh, no, because we're talking about the adapters, sorry. So right over here is the adapter. We were talking about the port before, but now the adapter is a concrete implementation for that. Okay. That will implement the port. Okay. So pretty easy in the way that works. The out adapters. Again, JPA, Kafka, REST client. So if you need to make a RESTful call to something else, your adapter is going to be that concrete implementation. And that's the idea for that. Now, we can use various names for this, and these are just opinions on my part here. But you can have naming conventions for that. So if you have an interface for a repository, then you can have a port interface like order repository, which is going to be the interface as to how I want to persist order, for example. But the adapter can be JPA order repository, Mongo order repository. Publisher would be for messaging events. So if I want to send to Kafka or RabbitMQ, then I can have the specific implementations for that. External API for REST, right? So I could have a REST or gRPC protocol or any other kind of protocol. So if I want to make an external API to that, I can do so. Email and notification. Typically, I like to go with sender for that. So the interface there would be a sender. So if I need to send messages via SMTP or SES, that would be the name of the interface that I would use there. File storages, S3 buckets, local file storages. And what's this thing here, LLM and AI service? I don't know if there's quite a standard quite yet, but this is, this is becoming, a part of our everyday application. A lot of you have attended talks for RAG and what's the other one? Model context servers and protocols and how you communicate and how you interact with LLMs. Have a standard for that and have an interface name that represents that. Payment gateways, searching, etc. So these interfaces, you have, just about everything that you need here. Just have a standard naming convention and you should be good to go. Now let's take a look at the folder structure as to how this would look. And here it is, right? Or here's just my way. And if you take a look at other people's ports and adapters architecture, everyone's going to have their opinion for that. But the idea is, however you want to go about it, I have the application layer, the domain layer, and the infrastructure layer, okay? So right over here, let's focus on the domain. So here in the domain is where my business classes are going to be. And again, no referencing to the outside world. The application port, again, we're going to have, this is where it's going to, where I'm going to be putting the components for the items that are coming in or going in, and then the items that are going out are going to be here in the application port. Okay. Let's take a look at this one over here. And here's this one. Okay. This is for the infrastructure. So for the items that are coming in. So this typically would be like if you're doing a Spring Boot, this is where you would have your Spring Boot application. But then right over here, you would have your concrete implementations for the port that you're developing. Again, everything having its place. Okay. You could do Spring, you could use Quarkus or however you'd like. This is just going to be an organizational thing that you would be using. Okay, excellent. So that's my typical directory structure. And again, you can have your own. All right. So next what I'm going to do is let's fill it with something simple and see where everything takes place. And again, what I wanted to do with this particular example is really just show a minimal application and how things work with each other. Okay, so I have the domain here, and I have the runner. I didn't invent this one. This comes from the book. So let's see. Where do I want to take a look at things first? This one though will not have a domain, and I'll talk about a domain in a complicated project. So the domain's going to be empty here, but let's take a look at the in and out. I'll go ahead and start there. So in the book, their opinion is these interfaces should resemble a use case. So this use case here is for calculating taxes, right? The use case for out is for getting tax rates, right? I'm trying to calculate taxes for something of a scale, And these interfaces are going to represent the ports. Again, the ports are just going to be interfaces, and that's what we're looking at here. So, excellent. So for the calculating, here it is. Public interface for calculating taxes. So in this case, this is the item that's coming in. Let me fix that zoom here. There we go. So this is the N. So this is coming in for calculating taxes, and I have a tax on it here. It's the way that I'm going to be driving my application. That's what that port represents. On this port right over here, I have tax rate. That's going to be on the out because my application is going to need to get a tax rate from some RESTful client or messaging system or database or something else like that. And that's what this interface represents. That represents the out. So coming in here is the infrastructure where I have this in right in here. And this is the implementation. This is the implementation on how a framework can grab this implementation for the tax calculator, connect it together. The repository is representing the out adapter, and this is the in adapter. And it's kind of like merged right here in this particular application, where I'm bringing in this repository and I have this taxon for this particular amount. And what I'm going to do is I'm going to take this tax repository here, get the tax rate, and multiply that by the amount. So everything has its place. What does the repository look like? Well, this is a very simple application here, but again, this is where your database calls are going to be. This is where your messaging systems are going to be. That's the reason for this right over here, and I'm just going to represent 15. Okay. Now, I have this runner in here where I'm just going to wire all these items together. And so what I'll have here is the repository. I will instantiate that, and I'm going to go ahead and wire that into this tax calculator and take a look here and see what everything looks like. And there it is. Okay. Very simple application. And again, everything has its place. Cool. DTOs. So data transfer objects are used in the infrastructure layer. And one of the reasons for this, let's see if I have, nope. Oh, let me come back over here. So on the infrastructure level, the adapter that you have here may not necessarily be what you want inside of the domain. And so one of the things that you'll do as part of this architecture is have a DTO, which is a translation, okay? In architecture, there is going to be a need to translate, from the adapter to that domain, called an anti-corruption layer, right? Because the thing that you're calling isn't necessarily the thing that you want to handle within the domain. So you're going to have to pick apart the pieces that you would like. And so that's where that would take place in that infrastructure level. So coming back over here, you may need to use DTOs. There are, a few applications within Java that would do the object mappers, and you can use that, or you could just do this hand-coded. So this is a way that you can change objects that are done in the infrastructure level, and then, reinterpret those for the particular domain. So for integration testing, this architecture is a great way to, handle testing because everything has its place. So you could do tester in development, particularly for the domain, and that should make things easy because it's just in one single place. You have your pure functions, you have your value objects, and input ports can be tested with mocks and output ports. Ensures that things are going to be fast, isolated, unit tests without databases. So that's just going to be one layer of that development. And that's just going to be here within that particular domain. Okay. Now, end-to-end testing, how is it that we're going to be doing that? Well, for something like this, what we get to do is these components up. So right over here, I could say, well, I'm going to be bringing in the CLI here, and I want to put some inputs over here on the CLI, and maybe I have an in-memory database or a test containers that's going to represent Kafka or RabbitMQ on the other side, where I'm going to be able to do an assertion on that end. So that's going to be your end-to-end test, and this architecture makes that easy as well. What about behavior-driven development? How many of you do BDD or acceptance testing? Okay, so this one is when you get together with your three amigos. And your three amigos are your testers, your developers, and your stakeholders, okay? So for those situations where you want to encode the business rules, this is great as well, because everything, again, has its place, and it's easy to do so because everything is going to be in that domain, right? The domain is going to represent your business functionality. And so you'll typically use something called Gherkin, which is your given, when, and then testing. And so that's going to be here on that particular domain side as well. Okay. Data-driven testing, which is using test containers. So on that side over here, this is going to be, hey, I want to take that port here and test the adapter on there so that way I can have that level of testing. That's going to be excellent as well. So everything has its place as far as the testing goes. Okay. Now, if I want to, I could also do this. Hey, bring in the domain as part of this, and let's go and test that component as well. Okay? So very awesome in the way that works. So let's demonstrate the testing harness here. So I'm working up a sweat over here. It's a little warm here, but here, let's come in over here. So what I have here is I have a full application. And I'll talk about some of the other components here. So in this one here, what I have is aggregates, I have services, I have an application. So I have something a little bit thicker here as far as this application goes, and I have ports, which I have only out ports on this one. But the idea for this is I'm going to have an order, and I'll talk about why I have all these classes here. I'll have a customer in here, and I will have a product, okay? So, again, I'll discuss what all these particular classes are, and I have a service in here, which is going to be represented within the application. In the infrastructure here, I have nothing right now, but that's okay. And I'm going to come over here to the test, and here in the test, what I'm going to use right over here is... let's go to the domain here, and here I have the order test. So given those orders here, I just have a unit test, which makes it easy, right? And so all I'm doing is just testing against the domain. So if I have an order and I'm adding order items to it, I should be doing an assertion here, but here's an assertion right over here. So given 3 add order items on here, when I execute submit order and I grab the state, then the state that I should have here is order submitted, right? And so these are just the unit tests against that particular domain. Okay, so that just shows a unit test there. Now, if I come in over here, let's go to this one right over here. Give me a second. Here's an example of an acceptance test, which I'm doing as part of a separate project right over here. And here it is. This one's using Cucumber. And let me start here with the resources here. And here's what I have here, okay? So what I have here is I have these calculations in here. This one's a gherkin. So given a customer, and typically what you want to do with any kind of acceptance testing here is you kind of want to word it like this. As a customer, who is the one that is interested in making sure that this is going to be correct, okay? As a customer, when I create an order with a number of items, the total should reflect the items and the quantity that's added. So given this here, this is given a new order. When I add the following order items together, here I'll have a table for the different items that I wish to add together. When I do all this, this is what the total should be, right? This is an acceptance test. But the idea for an acceptance test here is that it should reflect upon the person wanting this, right? And that's the acceptance test. The way this works is you'll end up creating a test. Now, before I continue on, this right here you generate as a meeting with your stakeholders and your testers is the way that works. And that's what this is. You kind of want to keep this as a text. You don't want to do any kind of coding, and that's not what the point is. The point here is to take down the requirements and write them down. The implementation and how you wire things in later is going to be a separate concern. And that's what that is. So I have this feature here, IntelliJ. It makes it look really nice right over here. And what I'm going to do is I'm going to go here to order steps. And this is the glue that is used to wire everything in. So here's how I end up doing it. Given an order, what the total should be. Notice this right over here, this language that I see here. Notice what that maps to. That maps to this. Here, let me highlight this. Then the total should be int. Well, then the total should be int. Notice how the wording is the same here. That's what the glue code is. We're just going to be wiring that part together. Okay. So, and here are the following items where I can get a data table to work all that out. Now, I'm going to come in over here and bring in the order feature here and run this particular test. Okay. And so I get a green bar there with a couple of warnings, but I end up with a scenario, 3 steps, and everything passes. Okay. So as far as testing goes, if you have any problems with, testing for acceptance testing or end-to-end testing, everything has its place and it should make that testing easier for you. So if you're suffering in that regard, then take a look at that. Okay, excellent. So again, what about LLMs? That's just an interface, right? It's a new world, but this makes it possible to integrate those LLMs. So have something called LLM client. And so if you're wanting to connect to your OpenAI, it's just another service that you have in the outside world. Now, where does domain-driven design come in all this? And how does it relate? So one of the things that I absolutely like is domain-driven design along with ports and adapters architecture. So let's discuss what this one is. So a little bit about domain-driven design. Domain-driven design is all about finding a dictionary for your business. And what do I mean by that? It means use their language, right? Use the business language that you're writing the software for, okay? They have their own language. Then what you do is once you have that language, they could be sentences, they could be words, but once you have that language, what you'll do is you'll draw circles around it to where you find meaning. And if you're in my DDD presentation, when I was in a lot cooler room, but if you were in that particular presentation, one of the things I had mentioned was, what's your favorite football team? And if you weren't in that presentation, that's the one that I'll usually use as an example. What's your favorite football team? Well, if you're in India, or if you're in Europe, your football team is going to be, as we Americans call, soccer. It's going to be a soccer team, right? But you have your favorite Indian, soccer team, or maybe you're a fan of the European soccer team. So likely when I ask you, what's your favorite football team? You're just going to come up with, you're going to say, this is my team. Where if you ask me or any other kind of American, what's your favorite football team? There's a good chance it could be a soccer team, but because of that bounded context, it's likely going to be, the U.S. football team. But that's a bounded context, right? There's a ubiquitous language to it, the football, but depending on what the bounded context is, it has a different little bit of meaning. Same thing goes with business. This is why you have an anti-corruption layer when it comes to architecture, because one bounded context goes about its own way to, say things, but a different bounded context has another, okay? So that's what DDD brings. Well, what does that have to do with ports and adapters architecture? So it's how you bring in that domain, right? This is very domain-centric. So the domain that you create is going to be that inner hexagon. And that's the point of all this. So one of the things that we could do is this really defines and really enshrines how you should write that inner domain hexagon that we were showing there. And you could do it however you'd like, but this provides a little structure to it. And DDD has these things called tactical patterns for things like aggregates, value objects, domain events, domain services. And so they tell you these design patterns that you can use within that particular hexagon. That's what that is, okay? Again, no infrastructure, no technology, but what you have to adhere to here is the ubiquitous language. Remember, part of this DDD is finding a language that your business uses, and that's the idea for that. So we have all these different items in here. So let's do a little quick intro here, and if you're in my DDD, this is going to be a little bit of a repeat here. Value objects are classes that don't have an identifier, but they're a class that wraps around it, okay? Value object, okay? You don't see like an employee ID or anything. Great for color, great for social security number, great for employee IDs. Those are value objects. Let's see, do I have internet here? Yeah, maybe. Like one of my favorite ones is Scala Squants. I know, funny name. Hey, I got internet here. Check this out. So right over here, I have Squants. Anyone hear of Squants? I know I'm probably not going to get a hand here. But let's take a look right over here. Look at that. Terrible. So this one says load kilowatt 1.2, energy megawatt hour 24.2. And is anyone stopping me with this? No. Because what am I doing here? Just dealing with doubles, right? Anyone know what this code smell is called? When you're just dealing with the primitives? That's too much of a hint, probably. Anybody know? Primitive obsession. Yeah, nice job on that one. You're obsessed about the primitives. You're using primitives for something that, you really shouldn't, for kilowatt or things like that. And this is where you bring in value objects. Kilowatts, 12. Well, in Scala, you don't have to use the new keyword, but you could do this in Java very easily as well. And so this has a type called power. Using a representational type is what we call it, right? And so if I wish to, add one load to another, even though one is kilowatts and one's megawatts, it allows it, right? And it does the things behind the scenes with each of those objects. That's what a value object does. Newer version of Java that's coming up is going to inline these value objects. So they're going to make them primitives behind the scenes. So that way you wouldn't have to put them on the heap. So things are becoming more efficient in Java if you start to use the value object. So get ready now. Okay? Excellent. So that's what these value objects are. Entities have an ID. So take a look at the bottom right-hand side. I have an employee ID with a name, right? That's an entity, something that has an ID associated with it. But we typically don't use entities in of themselves. What we do is we end up using entities with what are called aggregates in DDD, right? These are just design patterns that DDD brings, again, which allows you to design the domain in a certain way. So the aggregates are looking like this. So what's an aggregate? Order to order item, for example. Album to a list of tracks, right? Those are aggregates. One owns the other. Domain events are things that are happening within your object. This just happened, this just happened, this just happened. So if you're thinking about doing any kind of what's called event sourcing, for example, you capture these particular domain events as they're happening. You can put a timestamp in them. And if you want them, you can emit them from, your application, or you can, change the way it looks before you send that out into a messaging system or something like that. A very important point in how you want to design software, because especially if you're going to be doing managing, you want to have ways that you manage the domain events. And I'll show you how that looks. So from that aggregate, it emits domain events. And then from there, you could send it to whatever, subscriber that you're needing to, or, translate the message before it goes out. And I think this is the important one, and many of you saw this in my DDD talk, but if you weren't in my DDD talk, I think this is a really great image. And so one of the things that you'll do when you design this software is you'll have the following. So in the green here is what's called the aggregate boundary with ticket, message, and attachment. That means that if you're dealing with ticket and message and attachment, you're hardwiring in, well, not hardwiring in, but you're using the object graph for those. So ticket will have a reference to message, and message will have a reference over to attachment. Everything else outside of this boundary is going to have a reference only by ID only. What? Only by ID only, which means you reify that afterwards. And what does that mean? Well, if I want to tie in the ticket to a customer, to a product, or to an agent, I do that after the fact, right? So if I'm loading this from a repository, I'm going to be loading up the ticket, the message, and the attachment. But everything else is going to be referenced. Cool? Weird. So here's an example here, right? That ticket. Notice the customer is just using the user ID. Notice the products are just using the product ID. Notice the agent is just using the user ID, but when you take a look at the messages, that's being referenced, to an actual message. Because what you don't want is you don't want within your domain huge object graphs that are just like really hard to manage. So DDD kind of forces your thinking to dealing with aggregates and aggregates in the small. What's the benefit? Testing is a heck of a lot easier. Maybe loading things up from a database may have a little bit of a complexity there, but maybe not, right? But, keeping these aggregates small, is a great thing to have. Domain services is if you have multiple aggregates and you need something done, domain service will just use both of those aggregates together to perform some sort of job. And that's what you would put inside of the domain, right? And those are the design patterns of the domain. This has nothing to, well, I shouldn't say nothing, but this is just domain-driven design. Not really ports and adapters architecture, but when you bring those together, teardrops fall and you're like, hey, yeah, that's a beautiful thing, right? And that's a great thing to have around. Okay. So application services are where then you would wire this. It's still a DDD pattern, but this goes into the application layer. It just so happens that all this fits together. So this is where you wire in a repository and you would do something like persistent order. Now, oh man, here's really one of the great parts here. But here, let me go over to this code here and kind of show you that in action here. So here's my order. And let's take a look at that right over here. Right? Here's order. The thing about a aggregate is that, so I have order and order item, which would make sense as an aggregate. I have a hard code reference to order item, but for each order item in here, I only have a reference to a product. Because the only aggregate that I want here is order and order item, that's it. That's my boundary. Everything else just needs to be reified later. Cool. But also, let's take a look at the order here. I have rules within here. Let's say, for example, here, the submit order. If this order has already been canceled, don't allow that to go in much further on here. Okay? Great stuff. Okay? So I have rules in here, but I also have the following. And for all those of you that attended my DDD talk, a little bit of a repeat here. But take a look here. When someone creates an order, I create a domain event. If someone submits an order, I'll create an event here, okay? And if I wish to send those out into a messaging system, I could do so, right? That's really nice as well. Now, let's come in over here because I want to talk about my favorite part, transactions, okay? So when you store things onto a data store, you need a transaction for that, particularly if you are storing things across, two different repositories. Like, how do you go about doing that? This is the hard part. So application layer coordinates the use cases. Domain layer should be unaware of the transactions. When you do the domain, there shouldn't be anything in there that says at transaction or commit or rollback inside of the domain. That's an outside concern. Infrastructure provides that mechanism for the transactions and helps maintain a separation of concerns, okay? Domain models stay pure, no I/O or anything like that, but infrastructure stays swappable, an important part there. So if using DDD, application service is where the transactions should be assigned. Now, I think many of you have done this, correct? At transactional, where do you put that? Well, on this one, it's typically on the service. I've been staring at this thing for the large majority of the year and just staring at it and staring at it and staring at it and wondering to myself, why is that there? And it should be there. I'm not saying it shouldn't be there. It should be there. But transactional is a database thing, and this is in the application layer, not in the infrastructure layer, right? Did that ever seem weird to you, or is that just me? Like, why that transactional is there? So let's see, where do I have my, let me bring up this right here, right? Which is the application layer is the one that's going to have the at transactional, but the database stuff is not there, right? The database stuff is on infrastructure, right? That seem odd to anyone? Maybe. So let me come back here to the transactions here. So you do this, and again, nothing wrong with that, right? Spring and Quarkus have their way, making it easy for you, and on your service layer, you have an at transactional. Okay. It drove me nuts, but it doesn't have to drive you nuts. What if you don't have that? How do you go about doing that? Well, there's a couple of patterns here. Unit of work pattern. Anyone hear of that pattern? Unit of work pattern. This is, if you do .NET, this is a very popular pattern that .NET users use in order to do the transactions. Here's what that looks like. You have an interface for that unit of work, and let's say I have a JDBC unit of work, I would implement those. But what that would do is it would manage the transactions within this one particular object. It's an old classical pattern from the early 2000s, and that's the way that would work. And so here's an example of that unit of work and how that would work. Unit of work begin, and again, this object is the one that's going to be holding on to the entire transaction as you use it. And notice in here why this is a difficult thing. Right over here, I have customer repository and order repository with .save on it, right? I'm trying to save things across two different repositories, but under the same transaction. You see how this gets difficult? This is a hard part here. So given the unit of work, that's a nice way to go about it, but that's not the only way to go about it. This one I was just thinking of very recently. Have any of you used scoped value yet? This is the inheritor to thread local. So for this one of the things I don't want to do is I don't want to carry a connection, through a parameter, to a function parameter, to a function parameter, blah, 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 and, carry that all the way down. Well, this one over here is scoped value, and scope value, one of the things that you get to do here is map that connection, but one of the great things about that is you don't have to give customer repository that connection, and you'll notice in here your code is clean. Neat, right? Because this right here is going to put that connection on a thread. So it's kind of like thread local. And so anywhere in here, they can go ahead and grab that connection whenever they need to. And this is a part of new Java, brand new bleeding edge Java, okay? Here's Scala. You knew I would bring it up. No, you probably didn't know that, but I'm a big fan of Scala. Anyone had deal with effect systems? I think someone's going to have a talk on this as well, like a 30-minute talk on it. This right here is, I think, amazing. See that F and G right up in here? This is what we call a higher kind of type. Okay, cool, right? HKT. You know how you have list of E? You have the bracket there, and E represents whatever it is you want to put in that list. What if I genericize the outside? And so the idea for this, and I love it, is that you get to focus on this part right over here, which is your business, right? That's what this is, which is get things from a repo, wherever you are. Yeah, right over here. Get things from a, nope, that's not it. What am I staring at here? There we go, customer repo. And in this case here, I want to get the customer. I want to infuse that with the order, and I want to save the customer if it's a new one, and order repo, I want to save the order if I need to as well. Now, the funny stuff is this, monad. Anybody know what a monad is? Okay, monad is flat map, right? Don't let others tell you it's a giraffe or burrito, an elephant, or anything like that. It's just something that has a flat map. So G of, or let's use F of something, which would be a list of something, a future of something, an observable of something, a something of something, a something of something, a future of something, right? It has that shape. So this just means, hey, just make sure this has flat map because I want to use flat map for that. I don't care what that is. I just want that to have flat map. Cool. And with flat map, I get to do all this kind of good stuff here and just focus on the business side. Now, what is this function K over here? Where are we? Function K, using function K. This right here, and here's the, oops, sorry. You didn't see that? All right. So right over here, I have function K. What is that? So F could represent something, right? Like a list of something. G represents a different kind of something, like a future of something. Well, F is, we have certain types in Kafka that represent a database connection. There's something called Slick, which is DBIO. There's something called Doobie, which has connection IO, but it's DBIO or connection IO of something, right? Just kind of like a list of integer. Well, that's what this F represents. So that represents the database connection. The G on this hand, on this other hand, could represent what you want in return, something else entirely different, which in this case could be a future. So what this FK is, it's not a bad word, it just means function K, means that I can give it that program, and behind the scenes then I can do my transactions, okay? This is a functional way to go about it, which is do things at the very end, called the interpreter. Remember the interpreter pattern? I did one talk last year on the interpreter pattern. It's back, right? And so given that in a functional programming sort of way, that makes things nice. And so there's my Antonio Banderas in here. And I really, really do love this. So if you want to think about effects, take a look at type level cats, because they're the ones that, that's one big library that uses. So huge win in this case for using DDD along with the ports and adapters architecture. So you could use it with DDD, but produces really nice patterns for things that you could do inside of the domain. Okay. Let me just state this, and I'll just go and wrap it up here because you kind of saw the full application anyway. What's a microservice, and what does this have to do with ports and adapters architecture? Well, you kind of see that already, right? You have your inner core, you have your application as to how that's done. You have clear boundaries, encourages autonomous testable services that evolve independently, and you have everything in its place. This is your microservice, right? And so you could develop your microservice around this ports and adapters architecture. And the idea for this is, how are you going to wire things in? Maybe using a terminal with SSH or TLS. Let me get a little bit modern here. You have HTTPS coming in here. You're communicating with your Kafka or your RabbitMQ on that side. And why did I put the database there? That one's weird, right? Just because typically your database is going to be within your microservice boundary. It's not going to be, something hanging out outside. So that would be the boundary, and that's why I created it like that. I can have, a Kafka service called multi-tenant service that is going to be where messages are going to be done. And so these can communicate with that particular messaging service, okay? You know how to do that now, right? And you know how that's going to be developed. And so each one can be its own deployed microservice. I do see microservices as a deployment strategy. And so these can be deployed as is. But if you want to, you could just do this, right? Whereas each one is its own modular microservice that we see here, okay? But each one can have their own. Let me just state, and I'll finish on this point here. If you find yourself not using the domain layer just because you're hitting the repository and just getting information back and not having any kind of complicated domain along with it, maybe ports and adapters is a little bit, too much for such a simple thing. And maybe you just want something that is just quick and easy for that. But for the most part if your domain is going to be very complicated, this is a pure win sort of way to design your application. All right, I'll leave it there. Thank you very much, everyone.